Okay, the solution for the trigonometric identities mock exam. A spring is suspended from the ceiling. It is pulled down and released and then oscillates up and down. Its length, L centimeters, is modeled by the function L equals 33 plus 5 times cosine of 720 t degrees, where t is the time in seconds after release. Find the length of the spring after 1 second. Okay, basically what you have is a spring hanging down, and you don't need to draw this picture, but it kind of helps maybe to understand. And when you pull it down, it stretches, and then when you release it, it's going to go up and down, up and down, up and down, okay? And it's going to make a like a trigonometric function wave here. So the length of it, which is this, is going to be modeled by this cosine function. Okay. So first it just says, what is the length of the spring after 1 second? And we know that t is the time after 1 second. So this is very easy. You just plug it in here. Cosine of 720 degrees, and if you put 1 in there, it's just 720 degrees. Now, remember 720 degrees is double 360 degrees, so basically if you look at the unit circle, you just go around twice. It's the same thing as going around once. So the cosine of 0 degrees or 360 degrees or 720 degrees, it's all the same. The adjacent is 1, the hypotenuse is 1, so it's 1, right? And then, so that's basically saying 33 plus 5 times 1, which is 38. So the length of the spring after 1 second is 38. It doesn't, centimeters, I guess, yeah. It says centimeters. Find the minimum length of the spring. Okay, so, given this function, 33 plus 5 times cosine of 720 degrees, you could, say, okay, when exactly is the minimum? But you know that when you have a cosine function, the maximum or the most extreme values it takes are between -1 and 1, -1 and +1. So to make the length minimum, you would make cosine -1, right? So that would be 33 minus 5, right? Because 5 times -1, which is 28. Okay, so the minimum length of the spring would be 28 centimeters. What would be the maximum length of the spring? Well, it would be 5 times +1, so 33 plus 5 is 38, which is what you got for the first part. Okay? Find the first time at which the length is 33 centimeters. Okay, so let's see. You have this function, and we could draw the function even though we don't have to. We know that the d value is 33, so it's going to be centered at a height of 33. And then it's a cosine wave, so it starts at the maximum and then goes up and down. And the amplitude is 5, so the maximum is 38, like we said, and the minimum is 28, like we said. Okay? And it says find the first time at which the length is 33. It's right there. Okay, so if you look at a cosine wave would get to the center value at 90 degrees, right? If you look at the unit circle, the cosine of 90 degrees is 0 over the hypotenuse of 1, right? So we're looking at pi over 2 for 90 degrees, right? And in this case, we need to see when is the inside of the cosine going to be 90 degrees? Okay, so that would be let's see, cosine of 720t. When is this part here going to be 90 degrees? So to figure that out, we go 720 t equals 90, and then we say t is equal to 90 divided by 720, okay, which is equal to like 1/8, okay? So t is equal to 1/8 of a second. What is the period of motion? Okay, remember that the period we get by doing 2 pi divided by b, okay? And in this case, instead of 2 pi, we're going to put 360 degrees because we're doing it in degrees, okay? And our b value is 720, right? So our p value is going to be 1/2. So the period of motion is 1/2 a second. Okay. Next problem. Straight line with equation y equals 3/4 of x makes an acute angle theta with the x-axis. Okay, so now you're going to like make a line. You're going to graph it. And its slope is rise 3 over run 4. Okay, that's the slope there. And the angle that you're making with the x-axis is theta. Okay, so let's write down the value of tangent of theta. Well, remember, tangent of theta is equal to opposite over adjacent, which is equal to 3/4. Okay, so 3/4. It happens to be the same as the slope. Find the value of sine of 2 theta. Okay, let's remember the formula sheet. The formula sheet says that sine of 2 theta is equal to 2 sine of theta times the cosine of theta. Let's see. From this drawing, can we figure out the sine of theta and cosine of theta? Well, do we know the hypotenuse? Well, we could use Pythagorean theorem. We know that the hypotenuse is each side squared and added together, so that would be 3 squared plus 4 squared is 9 plus 16, 25. So this would be square root of 25. Wait a second, square root of 25, that's 5. And now you might remember the 3, 4, 5 right triangle. Okay, this is one of the right triangles that has a whole number or integer sides and hypotenuse. Okay, so since we know that the triangle is a 3, 4, 5 triangle, it's very easy to figure out what the sine and the cosine is of this theta. The sine of theta is 3/4, right? And the cosine of theta is 4/5. So we can write it here, 2 times 3/5, and the cosine would be 4/5. So that would be 24 over 25. Well, yeah, 24 over 25. Okay. And then the cosine of 2 theta, we could use any one of the formulas in on the formula sheet, but there's one that's like 2 cosine squared theta minus 1, right? And let me just check to make sure that's correct. Yeah, that's right. So remember, the cosine of theta is 4/5, so it's 2 times 4/5 squared minus 1, which is equal to 2 times 16 over 25 minus 1, which is equal to 32 over 25 minus 1, which is equal to 32 minus 25 divided by 25, which is 7 over 25. Okay? 7 over 25. All right. And that's it.